Welcome to the session. Today we are going to discuss some of the short answer questions in fourth module, recurrence relation. So, generating functions. What is meant by a generating function? So here, whenever the sequence of numbers will be there, A1, A0, A1, A2 and so on, AN and so on. So this we are going to represent. Suppose there exists a function will be there, expands power series of x, which is of this form, A0 plus A1x plus A2x square plus and so on. Then this is known as a generating function for this sequence. If we are expressing the coefficients are A0, A1, A2 and so on. So it is a function. It is a function. F of x is equal to A0, A1x, A2, x square and so on. Then that can be written as summation of AR x to the power of R. Then that is known as a generating function for the sequence A1, A0, A1 and so on. A1 and so on. So now suppose if I am going to take an infinite series. Now let us say f 1 minus x whole to the power of minus 1. So it is I am going to get, this is the expansion is this. This is nothing but a generating function for the sequence. A0 coefficient is 1, A1 coefficient is 1, A2 coefficient is 1, A3 coefficient is 1 and so on. So it is the generating function. This is the generating function for the sequence 1, 1, 1 and so on. Suppose if I am taking 1 plus x whole to the power of minus 1. So which is nothing but 1 minus x plus x square and so on. Then we are going to represent that as like this. So then this is known as a generating function for the sequence 1, and here the coefficient is minus 1, and here the coefficient is plus 1, here the coefficient is minus 1. In general, if I am going to consider any by using a binomial expansion, if you are going to express in the binomial function. So if I am taking 1 plus x whole power n, so whatever the coefficients will be there. So this is nothing but a binomial expansion is corresponds to a generating function NC0, NC1, NC2, NC2, NC3 and so on. NC0, NC1, NC2 and so on. NC2. So this is nothing but only to the power of n. So up to n we are considering. The remaining terms will not be there. So the remaining terms we are considering it as 0. Now suppose there are some sequences are given. Now we are going to find what are the generating function for this. So here this is A0, this is A1, this is A2, this is A3. So it is given as A0 equals to 1, A1 as 2, A3 as 3, like this it is given. Now the thing is, what is f of x is, the function is, f of x is A0 plus A1x plus A2x square plus A3x cube plus and so on is the generating function corresponding to the sequence A0, A1 and so on. So here A0 is 1 plus 2x plus 3x square plus 4x cube plus and so on. So this is the generating function for this sequence. And we are going to represent this as 1 minus x whole to the power of minus 2. 1 minus x whole to the power of minus 2. And similarly, the next one is also in the form, only alternatively the signs will vary. So it is 1 minus 2x plus 3x square minus 4x cube plus and so on. So this is nothing but 1 plus x whole to the power of minus 2. So for this sequence, this is the generating function, or this can be the generating function. Suppose if I am considering this sequence. So first it is given f of A0 is equals to 0. A0 is equals to 0. So this term will be 0. And so it starts with x plus A1 is x and A2 is 2x plus A3 is 3x square and 4x cube plus and so on it will be there. So now if I am taking x as common, 1 plus 2, 1 plus, then this is 2x square. This is 2x square and 3x cubed and 4x power 4. See, A0, A1, A2x square, A2x square, A3x cubed, like that. So this will become 2x plus 3x square plus 4x cubed plus and so on. So this is nothing but x, and the expansion is nothing but 1 minus x whole to the power of minus 2. So this is the generating function for this sequence. And similarly for alternating series, then similar as previous one, then I am going to get x and 1 plus x whole to the power of minus 1. And the another one is, suppose here this will be A0 is 1 square, A1 is 2 square, A3 is 3 square, A4 is 4 square, like that it will be. So now f of x is equals to, what is that, 1 square plus 2 square into x plus 3 square into x square plus 4 square into x cube plus and so on. So this is 1 plus 4x plus 9x square plus 16x cube plus and so on it will be. It will be like that. So now we are going to find what is this expansion. What is this generating function for this? So I am going to write similarly, simple in the same manner. This is equal to this one. Now let us go for this. We are going to define what is x into, suppose I am going to take, this is the generating function for this. So now I am going to differentiate this with respect to x. With respect to x. So d by dx of x into 1 minus x whole to the power of minus 2, which is nothing but d by dx of, and the function is this. So x plus 2x square plus 3x cube plus 4x power 4 plus and so on. This is equation 1, let us say. Then I am going to differentiate it. So 1 minus x whole to the power of minus 2, UV method. So then x into minus 2, 1 minus x whole to the power of minus 3, minus 1. Then this is 1 plus 2 into 2x plus 3 into 3x square plus 4 into 4x cube plus and so on. So now this will become, so I am going to write this as, just I am going to consider 1 minus x whole to the power of minus 2, and then this is, I am going to take it as a plus 2x by 1 minus x whole to the power of 3, then is equals to 1 plus 2 square, 1 square x plus 2 square x, and next 3 square x square, 4 square x cube plus and so on. So now this will become, see, whatever equation 1 we have, the same expression. So this is equals to, if I am going to simplify this, 1 by 1 minus x whole square plus 2x by 1 minus x whole cube is equals to this expression. So if I want to simplify this, then I can get this as, I am just taking, so the right hand side, I am just taking this equation equal to, simplifying this, 1 minus x, and next this is 1 minus x, and next plus 2x plus 2x by 1 minus x whole cube. So it is nothing but 1 plus x into 1 minus x whole to the power of minus 3. So this is the generating function for this sequence. Now this is 1 square, 2 square and so on. In the similar fashion, we are going to discuss what is the generating function for 0 square, 1 square and so on. And similarly, we are going to get what is 1 cubed, 2 cubed and so on. Also, we are going to find the, in the same manner, we can find the generating function for those sequences. Now let us go for, see, another one is x to the power of 27 coefficient. See, here we are going to find out what is the quotient of x to the power of 27, x to the power of 27 in this expansion, So here, let us go for 1 plus, suppose if I am taking the expansion, let us say a plus b, I am going to write this as, this we are going to consider x to the power of 27, x to the power of 27 in this expansion. Okay, then I'm going to have, let us say, this is equals to, I'm going to take it as x to the power of 4, I'm just taking common, anything whole to the power of 5 will be there. So then this will become 1 plus x square plus and so on, whole to the power of 5 will be there. Then this is x power 20, and the whole expression will be 1 plus x square and so on. This is nothing but 1 minus x whole to the power of minus 1, and of course whole to the power of minus 5. So then it is nothing but x power 20, then 1 minus x whole to the power of, we are going to have 5, whole to the power of 5. So this is, I am just saying, this is plus, and here we are going to have minus 5. So which is of the form, let us, we are going to discuss 1 minus x whole to the power of minus n. 1 minus x whole to the power of minus n. So if we are going to consider the expansion for this is nothing but, so n plus r plus 1. So it is summation of n plus r plus 1 minus cr, r minus 1. n plus r minus 1 cn, and then x to the power of r is equals to 0 to infinity. This is the rule, the formula which is associated here, anything to the power of minus n. So x power 20, then this I am going to write summation, and n is equal to 5. So 5 plus r minus 1 cn, it is nothing but 5, and x is nothing but minus we are having. So 1 minus x, this is, so x to the power of r, we are going to take it as x power r. So then it is x power 20 summation, and 4 plus r, see r, this is not n, this is r only, and this is also r, then this is r, and x to the power of r. Now we required here r is equal to 0 to, then we required only x to the power of 27 question. So I am taking r is equal to 7. So put r is equal to 7. So whenever r is equal to 7, then I am going to have x power 20, and r is equal to 7 means 11 c7, 11, r is equal to 7, so 11 c7, and x power r is x power 7. So now what I am going to get, x power 27, the coefficient is 11 c7, 11 c7. So the coefficient of x to the power of 27 is, so 11 c7, 11 c7 is the coefficient. And here in the same way, we are going to find the x to the power of 27 coefficient, x to the power of 27 coefficient. In this, there is also similar to this. So x power 4 whole to the power of 5. Then the expansion is 1 plus 2x plus 3x square plus and so on, and we are going to get whole to the power of 5. So this is equals to x power 20, then, and this is nothing but, so 1 minus x whole to the power of minus 2. This is the expansion, earlier we discussed this, so it is nothing but this. So x power 20, then 1 minus x whole to the power of minus 10. So now this is x power 20, then we have summation n is 10 plus r, c minus 1, and c r, then x to the power of r, x to the power of r. Then r I am going to substitute 7, then put r is equal to 7, then we have to get x power 20, then summation 17, 16, c7, and next x power 7, x power 7. We are considering only for this. So now x power 27 and 11c7. 16c7. 16c7. So the coefficient is 16c7 is the coefficient for x to the power of 27. X to the power of 27. So like that we can simplify this, and here also in the same manner we are going to do the product is also in the same way we can get this. And now let us have this is given already we discussed. This is the formula for this. 1 minus x whole to the power of minus 1 is n plus r minus 1 cr x to the power of r. So just we are going to take it as this. We are considering it. This is the proof for this. And next x is equal to minus n is equal to minus 1. If I am going to substitute, this is a minus ncr and this one. So if you are going to simplify x power r on both sides, we are going to multiply and taking summation, and we are going to simplify this. Subsequently, we came to know 1 minus x whole power minus n is equal to this. So instead of to find the power 1 minus x whole power minus n, so for that we are going to use, this is the formula for that. And now some more problems. Let us we are going to have. So here one more concept. See here. X power 12. Find the quotient of x power find the coefficient of x power 12. X power 12 in the expansion x cubed into 1 minus 2x whole to the power of 10. Whole to the power of 10. See, this is a positive power. Earlier we discussed only the negative power. And some other problems will be there. So we are going to find the positive powers of this. So here, let us go for a plus b whole power m. And that we are going to write ncr and a to the power of n minus r and b to the power of r. So for this is for a plus b. And for a minus b, if I am taking whole to the power of m, this is summation ncr a to the power of n minus r minus b power r. So these are the two binomial expansions will be there. So in that we are going to consider the x power 12 coefficient. So here x to the power of 3 into 1 minus 2x whole to the power of 10. This x cubed we are going to take, and here 1 minus a minus b, this I am going to apply. So here ncr, it is nothing but 10 cr, a is nothing but 1 to the power of 10 minus r, and minus b is nothing but minus 2x whole to the power of r. Now this is x to the power of 3, and then this will become summation 10cr 1 to the power of 10 minus r, then it is minus 2 to the power of r, then x to the power of r. Then this we are going to consider just taking inside 10cr 1 to the power of 10 minus r, this is nothing but 1 only, and minus 2 to the power of r, then x power 3 plus r, taking inside this x cube into here. So now I am just to find out what is the quotient of x power 12. So just to put r is equals to 9. Then we are going to write the quotient of x power 12 is. So here just r is equal to 9. 10c9, and then 1 power 10 minus 9 is equal to 1, and then minus 2 to the power of 9. And of course this is x to the power of 12. So this we are going to get 10c9 into minus 2 to the power of 9. Minus 2 to the power of 9. So 10C9 is equal to 10 we are getting, and 10 and minus 1 here. So it is a minus 10 into 2 to the power of 9. 2 to the power of 9. So this is a way that we are going to find out the power of x power 12 in the positive powers. If we are going to consider, we are going to identify this. And another one is, let us go discuss x to the power of, find the another problem. So find the quotient of x to the power of 5 in 1 minus 2x whole to the power of minus 7. So here earlier we discussed this 1 minus 2x whole to the power of minus 7. So a minus b whole to the power of minus n. So this we are going to consider summation n plus r. So what is that? We are going to say this, if it is n, then what is the formula is n plus r minus 1 cr. Then I am going to take it as a minus r 2x whole to the power of r. What about n is equals to 7? So this is already we solved this. See, we derived this 1 plus x whole to the power of 1 minus x whole to the power of minus n is this. So the same we are going to take it as here n is equal to 7. So 7 plus r minus 1 cr, then 2 to the power of r x to the power of r. Then it is summation, then 8 plus r cr, then 2 to the power of r, then x power r. Now we are going to find the quotient of x power 5. So put r is equal to 5. R is equals to 5. Then the coefficient of x to the power of 5 is, so what we are going to have, r is equal to 5. So it is nothing but 13c5. 8 plus 5 is 13, and 2 to the power of 5. 2 to the power of 5. So this is the value or the coefficient of x power 5 in the expansion. Now, so this is a way that we are going to discuss whenever the positive powers will be there and the negative powers will be there. That is the only case that we have to discuss. And moreover, these are the, suppose then these are the some of the problems which are related to the some of the problems which are related to the short answers in this modules. So with this, I conclude this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.